Inshallah, this is the next class for the chapter functions of several variables of engineering. In this class, we are going to understand the formula of Taylor's series for a function of two variables. If we are having two variables x and y, how to find the expansion of a function using Taylor's series. So this is the formula. You see here, expansion of f of x comma y in powers of x minus a and y minus a. In powers of x minus a and y minus a. The formula is too lengthy, but there is some basics hints here to understand the formula. Now see here, f of x comma y equals to f of a comma b, x minus a fx of a comma b, x minus a, then y minus b. Here x fx, here y fy of a comma b. These are f of a comma b. These are the degree 1 terms. Now here you will get the degree 2 terms. Therefore, this is 1 by 2 factor. You know this formula a square plus 2ab plus b square, like this. This is the hint to by heart the formula. Like this is a square plus 2ab plus b square. X minus a whole square, because here square. Therefore, we are having x of a comma b. Plus 2a means x minus a, b means y minus b. Here we are having x and y, therefore we write x and y, xy a comma b. Here we are having y squared, therefore we write y of a comma b. So these are the first degree terms, these are the second degree terms, these are 1 by 2 factor. Now we'll get the third degree terms, that is 1 by 3 factor. You know the formula a plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube, like this. A cube plus 3a square b plus 3ab square plus b cube, like this. Now here we are having x minus a whole cube, because here cube we are having 3x. Here we are having x square y, means x 2 times, y 1 time, xy. Here you see here 3ab square, x is 1, y is 2, therefore xyy, y cube, therefore fy by a cube. Just I am explaining the some hint to by heart the answer. Same question, if it is given a equals to b equals to 0, expansion in terms of x minus a and y minus a is this formula. Expansion in powers of x and y, just x and y, that means a and b are 0. Then the series is called Maclaurin's. Whenever we put a and b as 0, then that will become the Maclaurin series. So in Maclaurin series, what is the difference? Just a b equals to 0. This formula will become, same formula will become in terms of 0. You see here, f of x comma y equals to f of 0 comma 0. In place of a 0, b 0. So this is x minus 0 will be x fx of 0 comma 0, x y. These are the single degree terms, 1 degree term. Now 1 by 2 factorial, in place of x minus a we write x square plus 2ab plus b square, xx xy yy. In the same way 3 degree terms, 1 by 3 factorial, a x cube plus 3x square y plus 3xy square plus y cube. Y cube means 3y, xy square means x, do y, x square y means 2xy. In place of a comma b we kept 0 comma 0. So these are the two methods. Just what is the difference between Maclaurin's? Means here we are expanding in terms of x and y only, whereas Taylor's expansion means we are expanding in terms of x minus a, y minus b. When nothing is given, just it is given to expand, then we use Maclaurin's. If it is given expand in terms of x minus 1, y plus 3, or x minus 2, y plus 1, like that, that we have to use Taylor's expansion. So let me do few questions on these methods. See here, next question. Let me do one question. Expand f of x comma y equals to x square plus 3y square minus 9x minus 9y plus 26 in Taylor's series of maximum order about 2 comma 2. What does it means? About 2 comma 2 means about a comma b. So we are having the values as a equals to 2, b equals to 2. About means about 2 comma 2 means this is a, this is b. Now let we do, before going to the expansion, before going to the formulas, let we differentiate this one, because we have to use the differentiations. So I'm starting with fx. See here, fx equals to differentiation with respect to x square is 2x We don't have x here. X is 1, 1 into minus 9, minus 9. We don't have x here, we don't have x here, 0. So now fy differentiation with respect to y. Differentiation with respect to y. We don't have y here, y square is 2y, 2 3s are 6y minus this. We don't have y, y is 1, 1 into 9 is 9, constant is 0. Now fxx, see here, again differentiation of fx with respect to x. Differentiation of fx with respect to x. Now d by dx of x is 1, 1 into 2 is 2, fx, then fxy equals to differentiation of fx with respect to y. Differentiation of fx with respect to y. We don't have y here, so it is 0. Now one more, fyy, fyy. Differentiation of fy with respect to y, this is 6. This is the first step. We no need to go for the third degrees. Why? If you go for xxx, we are having constants, so constants differential will be zeros. If you differentiate this or this or this, you will get 0 because there are all constants. If you go for xxx, that what does it mean? Differentiation of fxx with respect to x, because this is constant, is 0. So next degrees will be 0. So we do not use. Now what is here? We have to substitute these values. Fx of, what we have to substitute, a comma b, that means in place of x2, in place of y2. So we have to substitute 2 into 2 minus 9, this is minus 5, 4 minus 9 minus 5. In the same way, fy of 2 comma 2, 6 into y is 2 minus 9, this will be 12 minus 9, 3. Fx of 2 comma 2, because this is constant function we cannot substitute, so this is 2 only. And fxy of 2 comma 2, this is 0, constant function as it is. Now fyy of 2 comma 2, this is also constant, so we wrote this one. Next is the formula we have to write. Let me write the formula. What the formula we are having? Taylor's series is f of x comma y equals to f of a comma b. We have not find the a comma b. No, let me find this also. I am finding here f of a comma b means 2 comma 2. So we have to substitute the values of x and y here. See here, in place of x2, in place of y2. So what will happen if you put 2 here? 2 square 4. If you put 2 here, 2 square 4, 4 3s are 12, minus, if you put 2 here, 2 9s are 18, minus 18 plus 26. Once more, you see here, f of a comma b means 2 comma 2. F of a comma b means 2 comma 2. So if we put 2 here, 2 square 4, 2 square 4 3s are 12, minus 19 minus 18 plus 26. See here, 12 plus 4, 16. 16 plus 26, 12 carry 1, 42. 42. Once more, see, 12 plus 4, 16. 16 plus 26, 42. Minus 36. Minus 18, minus 18, minus 36. So 42 minus 36 is 6. So f of 2 comma 2 will get 6. Okay. So what is the next formula here? Plus x minus a into fx of a comma b. Let me write 2 comma 2 again. Why to write 2 comma 2? X minus a is 2, fx of a comma b means 2 comma 2, plus y minus b. B is also 2 here. Fy of 2 comma 2. These are first degree terms. Now what for second degree terms? 1 by 2 factorial x minus 2 into fx of 2 comma 2 plus x minus 2 y minus 2 fxy of 2 comma 2 plus last term is y minus 2 whole square, sorry, here also square, no? Whole square fyy of 2 comma 2. Now let me substitute the values here. Just now we seen f of 2 comma 2, we got 6 plus x minus 2 into x minus 2 into fx of 2 comma 2. Fx of 2 comma 2 we got minus 5. So let me write this minus 5. Fx of 2 comma 2 we got minus 5. So this finished, plus y minus 2 into fy of 2 comma 2 we got 3. So let me write 3 plus 1 by 2 factor is 2 only. X minus 2 whole square, x minus 2 whole square. Fx x of 2 comma 2 is 2. We can write 2 here. See here, fxy of 2 comma 2 is 0. Fxy of 2 comma 2 is 0. So 0 into a number 0, this 0, it becomes 0. So let me write this one, plus y minus 2 whole square. Fy comma y of 2 comma 2 is 6. Finish. So this is the answer. So because there are no higher degree terms, we no need to write plus 1. If we are having higher degree terms, we can write plus 1. But here it is finished. So this is the expansion for Taylor's expansion for the given question. Now you see the next question. Expand e power x sine y in powers of x sine y. Just to explain, if it is given like x minus 1 into y plus 1, x minus 2, y plus, like that, that a and b we can take. But in powers of x and y means we are having a equals to 0, b equals to 0. That is, we are using Maclaurin's expansion. Even we can say Taylor's expansion also. Maclaurin's is a special case of Taylor's expansion. So first of all, let me differentiate this one. Let me find few partial differentiations. Fx differentiation with respect to x. So this is constant, d by dx of e power x, this is constant as it is. Now fy with respect to y, e power x, d by dx of sine is cos y. Fxx differentiation of fx with respect to x. So we have to differentiate this with respect to x. Fx x, that means we have to differentiate fx with respect to x. So e power x will be e power x only, this is constant. Fxy, we have to differentiate fx with respect to y. So sine is cos, e power x cos y. Fyy, differentiation of fy with respect to y. So d by dx of cos is minus sine, e power x sine y. Let we go for the third degree terms also, because many will be become 0, because sine 0 is 0, this will become 0. We left with only 2 terms. Therefore let we go for one more for third degree also. What we have to take for third degree? Fxx of x. That means we have to differentiate fxx with respect to x, fxx with respect to x. So equals to d by dx of e power x is e power x sine y as it is. Now fxxy, we have to differentiate fxx with respect to y, fxx. So d by dx of sine is cos, e power x cos y. Fxyy, fxyy equals to, now what is its formula? Fx differentiation with respect to y, fxy with respect to y, fxy with respect to y. So d by dx of cos is minus sine, minus e power x sine y. Now lastly fyy, differentiation of fyy with respect to y. So d by dx of sine is cos, so minus e power x cos y. This is the first step. Now what is the second step? We have to substitute the points. So first this here, f of 0 comma 0, a 0, b 0, sine 0 is 0, 0 into a number 0. Now fx of 0 comma 0, again sine 0 is 0, 0 into a number 0. Now fy of 0 comma 0, watch carefully, cos 0 is 1, cos 0 is 1. E power 0, x is 0, y is 0, e power 0, cos 0, cos 0 is 1, e power 0 is 1, 1 into 1, 1. Now because sine 0 is 0, therefore fxx of 0 comma 0 equals to 0. Now fxy of 0 comma 0, cos 0 is 1, e power 0 is 1, 1 into 1, 1. Fyy of 0 comma 0, sine 0 is 0, therefore 0. Now next step is fxxx of 0 comma 0, because sine here is 0. Fxxy 0 comma 0, cos 0 is 1, so this is 1. Again fxyy 0 comma 0 is sine 0 0. Fyy of 0 comma 0 is minus 1, because this is minus, cos 0 is 1. So let me write the Maclaurin's expansion. Just now we have seen the formulas for Maclaurin's expansion. Let me write this Maclaurin's expansion series. What we are having, f of x comma y equals to f of 0 comma 0 plus x by 1 factorial, no need to write 1 factorial, x into fx of 0 comma 0 plus y into fy of 0 comma 0 plus 1 by 2 factorial x square fx x of 0 comma 0 plus 2xy fxy of 0 comma 0 plus y square fyy of 0 comma 0. This is second degree terms. Now let me write the third degree terms. 1 by 3 factorial x cube fxx of 0 comma 0 plus 3x square y fxxy 0 comma 0 plus 3xy square fxyy 0 comma 0. Lastly plus what is left here, y cube 3 fyy 0 comma 0, because the series can still expand, therefore we write so on plus so on. Now let me substitute. F of x comma y is nothing but e power x sine y. This is the expansion for this. F of 0 comma 0 is 0, no need to write 0, this is 0 left. Fx is also 0, no need to write this. Fy of 0 comma 0 is 1, so 1 into y will be y plus 1 by 2 factorial. Now fxx is also 0, so no need to write this. Fxy is 1, so 1 into 2xy 2xy. Fyy is also 0, to no need to write this one, plus now 1 by 3 factorial. F triple x is also 0, so no need to write, this is 0. F triple x is 0, and this fxxy of 0 is 1. 1 into 3x square y 3x square y 3x square y. Now what is the next term? We went to 3x square y 3x square fxxy is 1, and xyy is also 0, no need to write this one, so this is minus 1, so this will be minus 1, this is minus 1, so this will be minus y cube plus so on. No need to solve this one, leave this as it is, okay, or else just you can solve this to cancel, remaining is the answer. If you want to cancel this, don't add it this. If you add this one, you have to leave this as it is, okay, plus so on, because we can still differentiate, so you write plus so on. Now see here what we are having, f of x comma y equals to e power xy. One more thing is what is given in the neighborhood of 1 comma 1, that means a equals to 1, b equals to 1, a equals to 1, b equals to 1. So let me continue here, see here. So now let me first differentiate few terms. Suppose fx differentiate with respect to x, d by dx of e power x is e power x, but we are differentiating with respect to x naught, so you have to differentiate here also. D by dx of x is 1, 1 into y is y, so y you will get here. Now in the same way, fy differentiation of with respect to y, d by dx of e power x is e power x, but we are differentiating with respect to y, so d by dy of y is 1, 1 into x is x. So next one is fxx differentiation of fx with respect to x, you write y as it is, because we are differentiating with respect to x, this is constant. Now d by dx of e power x, e power xy, again we have to differentiate xy, d by dx of x is 1, 1 into y is y, again y means this will become y square. Now fxy, watch carefully, when we have to differentiate fx with respect to y, we have to differentiate with respect to y. Here also you are having y, here also you are having y, that is we have to differentiate uv. We know u d by dx of v plus v d by dx of v. Now we have to differentiate this with respect to y, so u means y, u d by dx of v, d by dx of e power xy is e power xy, but if you differentiate xy with respect to y, y is 1, 1 into x is x, plus u d by dx of v, plus v means d by dx of, sorry, d by e power xy, d by dy of y will be 1. You see, we have differentiated using uv. We know product rule, u d by dx of v plus v d by dx of y is 1. So what is left here? Fyy. So differentiation of fy with respect to y. Differentiation this with respect to y. So x is constant. D by dx of e power x is e power x. Again we have to differentiate xy with respect to y. So y is 1, 1 into x is x. Again x means x square. Now I left here. Let me stop here itself. Okay, second degree terms. Now what is a and b here? 1 comma 1. So we have to find f of 1 comma 1. If you put 1 into 1, 1. E power 1 is 1. E power 1 is, sorry, e. Here also, if we write fx of 1 comma 1, if we put 1 here, it will be e power 1 into 1 is 1. Fy of 1 comma 1, this is also e. 1 1 into e power 1 is 1. Fxx of 1 comma 1, this will also be 1. 1 square is 1. 1 into e power 1 is e. Fxy equals to, watch carefully, 1 into e power 1 is e, plus e is 2e. So lastly, this f, sorry, of 1 comma 1, fy of 1 comma 1, if you put 1 here, it will be e. Now what is the next step? You see here, just we got all the values e, except this we got 2e here. All the values are e. So next step is, let me write the formula for this. What is the formula? Taylor's series is f of x comma y equals to f of a comma b plus x minus a into fx of a comma b plus y minus b fy of a comma b plus 1 by 2 factorial x minus a whole square fx x of a comma b plus 2x minus a y minus b fxy of a comma a plus y minus 1 whole square fyy of a comma b plus so on. So no need to take the third degree. We can live here by using the condition so on. So f11 is e, we got this e, plus x minus 1, we got this also e, plus y minus 1, we got this also e, plus 1 by 2 factorial. This will be x minus 1 whole square e plus 2 into x minus 1 into x y minus 1. This term we got 2e. So just for this one step we are using 2e. No, I'm writing here 2e. This is left plus y minus 1 whole square. This value is e bracket plus so on. Just let me do it. Let me take e common from all the values. Let me take e common. So what is left here? 1 plus x minus 1 plus y minus 1 plus 1 by 2 factorial is 2 into x minus 1 whole square plus this 2 will become 4. 2 to the 4, x minus 1 y minus 1 plus y minus 1 whole square bracket plus so on. So these are the few questions we have done on Taylor's expansion for two variables. Okay, so you by yourself practice 1-2 questions more from the textbook so that you will get perfection over this. Okay, so inshallah we are going to continue in the next class with some other topic. Inshallah, I request you all to share, subscribe and like my channel. Inshallah, we are going to continue in the next class.